Welcome to the next chapter in this course, where we are going to talk about testing modular monoliths. Here's a brief introduction of what we are going to talk about in this lesson. I'm going to discuss what we should be testing and the various types of tests that we could write and what value they can bring to us. I'm also going to talk about code coverage as a quality metric, and I'm going to show you a few examples from the Evently codebase. After this initial discussion about testing, we're going to move into the practical part of this chapter, and we are going to write some unit tests and integration tests for the Evently application. When it comes to what we should be testing inside of our system and which kind of test we should write for a particular use case, we can refer to the testing pyramid for some guidance. At the bottom of the testing pyramid, we have unit tests. They are easy to write and very quick to execute, and this is mainly because they are testing small components of code inside of our system. Typically, you will be writing unit tests mainly for the domain entities inside of your respective domain layer. The classes that we define inside of our domain should not have any external dependencies, so it's easy to instantiate an instance of a domain entity, invoke the methods that we want on the entity instance, and then verify that we got the desired behavior out of invoking that method. We could also unit test our use cases inside of the application layer, and this would involve mocking any external dependencies, such as repositories, identity services, or any other dependencies that the use case requires. However, I don't think these types of tests are too valuable as opposed to the second type of test that we could write, and these are the integration tests, which sit one level above unit tests in terms of abstraction, and integration tests also test the code components inside of our code, but we can also use them to test the modules or the API, as well as the database or any other external service as part of an automated integration test. This type of test is extremely valuable because it can come very close to mimicking the real-world execution of your system at runtime. When it comes to using external services as part of your integration test, you really want to be using the actual service that you will be running in production. And the easiest way to achieve this is to run something like the database inside of a Docker container and then execute your test by connecting to that database instance running inside of a Docker container. Another advantage of this approach is that you will be able to execute these integration tests as part of your continuous integration pipeline. Most of the CI/CD pipelines out there support running Docker containers, which means you can easily introduce integration tests as part of your continuous integration pipeline. And I'm going to show you this later into this chapter. One level above integration tests, we have our end-to-end tests, which test the system from the perspective of an external user. This would typically involve spinning up the user interface of your respective system and then executing an action from the user interface. This would hit your API, the database, and also execute any required code. We can also come pretty close to end-to-end tests by writing integration tests inside of ASP.NET Core that just call the API endpoints of our system. Given that the API endpoints represent the input to our system, we would only be skipping the user interface, but we would be calling our backend in the same way, and we can just verify the response of our HTTP request and figure out if the test has passed or not. So this was a high-level discussion about the types of tests that we could write, and I'm going to show you how to write all of these types of tests. We are going to write unit tests, integration tests using Docker containers, and end-to-end or functional tests that will call our API using an HTTP client. When we are done with this chapter, this is what our test suite is going to look like. I added something around 250 tests into the solution, and this covers both architecture tests that we discussed in a previous chapter, as well as unit tests, integration tests, and end-to-end tests, both from the API perspective and also testing the integration between our modules. Here is a code coverage report that I generated using this test suite, and you can see that we have 76% line coverage inside of our solution, which is pretty good considering that we overall have around 250 tests. As far as the individual modules are concerned, you can see that the users module has an 86% code coverage, followed by the attendance module at 81%, and then the events module at 76%, and the ticketing module at 64%. Considering that the ticketing module contains the core business functionality inside of our system, it would definitely make sense to invest more time into writing high-quality tests for this module. Here's an overview of the code coverage for the users module, where you can see the individual code coverage result for the specific projects that I have in this module. And we have the integration events project with just 56% code coverage. Then we have the presentation project, an infrastructure project, at 70 something, and then we have the application and the domain projects from the users module at a solid 88% and 90% code coverage. Here's the code coverage for the ticketing module, and in this case you can see that the application and the domain projects aren't covered nearly as well as was the case in the users module. What's interesting is that we have the highest code coverage inside of the infrastructure project of this module, which also contains the least amount of business value. Most of the things that's going to make an impact will be in the domain and the application projects. If you are wondering how I am generating these code coverage reports, I am using an extension called ReSharper. It contains a lot of awesome features, and among them we can get unit test coverage. You're also going to see this warning here that I excluded some nodes from the code coverage tree. This is because I manually excluded EF Core migrations from my code coverage results. This code is auto-generated by EF Core, and we won't really be executing it during the normal execution of our application. And one more thing I want to comment on is the use of code coverage as a quality metric for your application. Code coverage can definitely be useful to help you figure out if you have parts of your code that need more tests, like in this example where we could definitely add more tests for the application layer of the ticketing module. But be aware that even if you have 100% code coverage, that doesn't mean that your system will be free from any bugs. So my rule of thumb when it comes to code coverage is to try to make it as high as possible, ideally around 90%, which isn't too hard to achieve if you simply test all of the use cases from the application layer, for example. However, trying to get 100% code coverage will probably not be worth the overall effort. So to summarize this discussion, code coverage is definitely useful as a guideline to where you should be focusing your testing efforts. However, this assumes that you are writing quality unit and integration tests to begin with, which are much more important when it comes to validating the behavior of your system and making sure that you don't have any bugs. So let's slowly wrap up this discussion about testing, and we can move into the practical part of this chapter where we are going to be writing unit tests in the next lesson.